Hello there, welcome to the June 2019 Core Paper 2 questions. Here we're looking at question 8. Figure 1 shows the central vertical cross-section ABCD of a paddling pool that has a circular horizontal cross-section. Measurements of the diameter of the tops and the bottom of the paddling pool have been taken in order to estimate the volume of water that the paddling pool can contain. Using the measurements, the curve BD is modelled by the equation y equals ln 3.6x minus k, where x is in between 1 and 1.18. Find the value of k. Okay, so it's probably going to be, so if we substitute in x equals 1, then we know that we're going to get 0 out of it. So therefore, if x equals 1, y equals 0, then we're going to get 0 equals ln 3.6 x minus k. So x is 1, so we just replace that with a 1, so it's 3.6. Now remember, it's ln of 1 that will equal 0, so therefore 3.6 minus k equals 1, so therefore k equals 2.6. So there we are, that's our answer for K. Find the depth of the paddling pool according to this model. Well, that's just going to be, so that's the answer for part A. Moving on to part B, that's just when we substitute in x equals 1.18. So therefore the y value is going to be ln 3.6 times 1.18 minus 2.6. And that gives us an answer of, type that into your calculator, yet ln of 1.648, which is 0.500 meters to 3 significant figures, so basically half a meter deep. Okay, so now that we know that, let's move on to the next bit. The pool is filled with water from a tap. Find in terms of h the volume of the water in the pool when the pool is filled to a depth of h meters. Okay, so this is our equation here, y equals ln 3.6x minus 2.6. Let's just go back to the diagram here. Now it's going to be the curve of this expression here revolved around the y-axis. So this is going to be a y-axis revolution one. So the formula for that is going to be pi times the integral. Now what height, it doesn't want it up to a particular height, just height h. So it's going to be the integral from h down to 0 of x squared dy. So what we need to do first is rearrange this little equation here to get x as the subject. So it's going to be e to the y plus 2.6, then divide by the 3.6 equals x. So it's now going to be that thing squared. So this is going to be equal to pi times the integral from h down to 0 of e to the y plus 2x, so 2.6 over 3.6 all squared. Now I think what I'll do is I'll divide that 3.6 squared to the front, so 3.6 squared, and then that will leave me just with the numerator that's being squared in this bracket, so it's going to be e to the 2y plus 2 lots of 2.6, 2 times 2.6 is 5.2, so 5.2 lots of e to the y. Now if you're doing this all in fractions, that's fine as well, and then it's plus 2.6 squared, 2.6 squared is 6.76 dy. Whoops, missed the dy above. Okay, let's now integrate, so it's going to be pi over 3.6 squared, and then it's going to be integrate, so it's going to be a half e to the 2y plus 5.2 e to the y, and then plus 6.76 y between the boundaries of h and 0. So the next thing to now do will be to substitute in h and substitute in 0 and then do the subtraction. So it's going to be in the first bracket a half e to the 2h plus 5.2 e to the h plus 6.76 h, and then it's going to be minus, because we will have to minus something here, because e to the 0 is 1, so that would be minus half, and minus 5.2, and then when you put 0 in for the last bit, that will just be nothing. So therefore, let's simplify all of this. It's going to be, in fact, let's rewrite this all in terms of fractions now. So if we expand the first bit, it's going to be pi divided by 3.6 squared times a half. So let's write that out then. 3.6 squared times 2. So that's going to be 25 over 648. 25 pi over 648 e to the 2 pi. I think I'm always prefer fractions. Then it's going to be 5.2 divided by 3.6 squared. And that's going to give us 65 over 162 e to the h. The next bit's going to be 6.76 divided by 3.6 squared. And that's going to give us 169. Oh, whoops, I missed the pi out in this one. Pi. 169 over 324 h. And then it's going to be minus. So now we'll have to do 0.5 add 5.2. And then divide that by 3.6 squared. And that will give us minus, oh whoops, I missed the pi on that bit as well, minus 95 over 216 pi. Okay, so there we are, that's the answer for part C. So this is the volume of the water in the pool when the pool is filled to a depth of h meters. Okay, so moving on to part D then. Given that the pool is being filled at a constant rate of 15 litres every minute, find in terms of H inverse the rate at which the water level is rising in the pool when the depth of the water is 0.2. So we seem to have lots of things going on here. We have H equals 0.2. We have the pool being filled up at a rate of 15 litres every minute. So what that's probably referring to is dV by dt is equal to 15 litres per minute. 15 litres per minute. And we also will probably be able to work out what dV by dH is equal to, and we want to work out what the rate of the height of the water level is increasing by when the depth is equal to 0.2. So we effectively want to work out what dH by dt is equal to, the rate at which the water level is rising, and the way we're going to be doing that is probably by, well, we've got a dV by dt, so we probably want to cancel out the dV and then do a dH on the top. So it looks like, yeah, it looks like we're going to have to differentiate this thing here, then flip it upside down. So let's differentiate this thing then. So it's dV by dH is equal to, it's going to be 25 pi over, then we move the 2 to the front, so 648 divided by 2 is 324, so 324 e to the 2h plus 65 pi over 162 e to the h. That just stays as it is because it's the self-differential. The next bit is going to differentiate to 169 pi over 324. And then when we substitute in h is equal to 0.2, this will give us the rate at which the volume is changing by with respect to how the height is changing. So if we substitute 0.2 in, then that's going to give us 3.5399 9 dot 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 dot. Now the key to this question here is working with the units that we're given here. At the moment this is increasing by the volume calculation is a meters cubed question. If you go back to the previous parts of the question, you'll see that the dimensions of this water container is in meters, so it's meters cubed, and then the height is changing with respect to the dimension of the height is also in meters. Now the key for this question here is we want to find the rate at which the water level is rising with respect to centimetres per hour. So I need to change this into centimetres. Well, actually, if we have a look at the units here, it's meters cubed over meters. So actually this is going to change into meters squared. This is the unit for the volume. This is the unit for the height. So it's effectively V over H. So it's going to be meters squared. So then how do we change a meter into centimeters? Well, it's 100 centimeters in a meter, so there must be 100 times another 100 because it's meters squared. So we're going to have to times that by 10,000, and we're going to get 35,398.95. Actually, it's 96. Dot 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 dot. Okay, so this is dV by dH. Now it's in centimeters squared. It's in the correct units. Now what we want to work out here is dH by dt, which is equal to, okay, so it's dV by dH is this, so dH by dV, and now we're working with this expression here, is going to be the dV by dH upside down, so it's going to be 1 over 35,398 dot 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 dot. We'll use answer button for that bit. Now for the next bit we need dV by dt. Now at the moment the unit is 15 litres per minute. Okay, and we want to now convert this into centimetres cubed per hour. So let's convert it into the per hour bit first. If it's 15 litres per hour, then it's going to be 90, hold on, let's just do it, 15 times 60, 900, so 900 litres per hour. And now the conversion for litres is 1,000, so it's going to be 900,000 centimetres cubed per hour, and that's exactly the right unit that we want here. So it's going to be times by dV by dt, which is equal to 900,000. Okay, so now the last thing to do will be to divide one by the other. So 900,000 divided by this 35,000, and we get 25.4 centimetres per hour. And there we are, that's the answer for this question here. So that's the answer for question 8 in total, worth 11 marks. So question worth 11 marks in total. So there we are, that's the answers for core paper 2, June 2019. Maybe let's now move on to the core papers for June 2020. Hopefully you found these videos helpful. Thanks very much for watching.